So that's something that you're going to want to do, especially if you haven't gotten to that lesson yet, or if maybe you've gotten there and you've taken the quiz and you didn't get a score that you wanted. I would go and watch those videos and then try again, just because remember you get 3 attempts on all your quizzes. So today we are going to be doing circles and volume. So let me get my screen share going here. Somewhere, there it is. Okay, so we're going to start with circles and then we're going to move on to volume. Again, those are 2 different lessons in the geometry module. And then at the end, if we have time, I have a quizzes game for us to do just to kind of practice both of those skills. So for circles, we're going to start with some formulas, but we have to introduce a term here that we haven't looked at in this class yet. We're going to be looking at the concept of this. Does anybody know what this symbol is? Yes, it is pi. Okay, not like the pie that you eat, although that would be fun to explore in math class, but this is a term that was made up to kind of show a relationship between circles, and there's kind of a long story behind it. But anyway, what we use, and yeah, a lot of y'all are getting it already. This has, if we were to type pi into the calculator, there's a little button on a lot of graphing calculators that is pi. And if you hit enter, it gives you like the big list that the number is equal to. Yeah, and it just keeps going. It's this big long decimal. But we have shortened it and kind of simplified it in most cases to just say 3.14 and say that that's what it's equal to. Okay, so sometimes when we're working with these problems, we're going to use 3.14 for pi, but sometimes we're just going to leave it as pi. And for today's lesson, we are going to leave it in terms of pi, which means we're not going to plug in 3.14. We're just going to leave the symbol. Okay, yeah, we are going to cover all of those things that you listed: radius, diameter, area, circumference, all of that good stuff. Okay, so that's what we're looking at today, or that's going to come into play here in just a little bit with our circles. But first, we do need to talk about the radius and the diameter of a circle. So let me put a pretty circle in here first. So if we're talking about the radius, and I'm going to go kind of quickly again because I don't have a whole lot of time. But if you need to refresh your memory on these, you can always go back to the lesson or rewatch this video anytime. So the radius says that we start at the center of the circle, so the very, very center. And it starts there, and it's a line that goes to any point on the circle. Okay, so that line could go from the center to any point on the circle. And this is called our radius. And then our diameter is similar, but instead of starting at the middle, it does what? Does anybody know what the diameter does? Yeah, that's true. It is double the radius. Yeah, it goes all the way across. But what's important here is that it goes all the way across through the center of the circle. Okay, it can't just go like this. Okay, that's from one point to another point on the circle, but it doesn't go through the center, so that doesn't work. It has to go through the center of the circle from one point on the circle to another. Yeah, that's true. Okay, so the whole thing then is the diameter. And since it goes through the center, that means it is twice the length of the radius, or the radius is half the length of the diameter. Okay, so if we know the diameter, so let's say our diameter of this circle they've told us is 12, then what is the radius? Okay, the diameter is 12, so the radius is smaller, and it's exactly half the size, so it is 6. Yeah. Yeah, diameter divided by 2, that's exactly right. Okay, so that's our diameter and our radius. Again, if it was too quick for you, since I don't have a whole lot of time today, I would go back to the lesson and kind of review those terms and the information that comes with those. Okay, so then we move on to the circumference of the circle, which is basically the perimeter. Okay, we use the word circumference when we're talking about circles, but when we're talking about other shapes like rectangles and trapezoids and squares, we call it the perimeter. It's kind of the same concept, but a circle is curved, so we don't have just like side links because there's no sides, right? It's just one big circle. Okay, so I'm gonna change the chat a little bit. I think it's getting a little off topic here. There we go. All right, so the circumference is just the length of, if we were to spread this circle out and lay it out as a line, then we could say that the whole circle is one line just wrapped around to meet itself. Okay, so the circumference is the length of the circle, or the line that wraps around the circle. Yeah, the distance around the circle. That's a good way to put it. Okay, so there's a formula that we use to find circumference, and to find it, that formula is equal to 2 times pi times the radius. Okay, so that's the same thing as just saying 2 pi r, because remember, if your terms are right next to each other without anything between them, it's understood multiplication. So 2 pi r, 2 times pi times radius. So if we know the radius, we can find the circumference of any circle. Okay, so if you notice, it's 2 times pi times r, and we know that we have a property that says we could switch the order in multiplication. So we could say 2 times r times pi, and 2 times r is the same thing as what? Yeah, well, yes, the diameter. Okay, if we multiply the radius by 2, that's the same thing as the diameter. So this formula is also the same as pi times the diameter, because 2r is the diameter. Okay, but technically, if we're looking at the circumference formula, it's going to look like this when you see it. Okay, but either one of those will work. Okay, so let's use that first example that we had where I said the diameter was 12 and the radius was 6. If we plug it in either way, let's do 2 pi r here and pi times diameter here. So if we plug it in either way, we have 2 times pi times the radius, which we all said was 6 earlier because the diameter was 12. Okay, and then over here, pi times diameter is pi times the diameter, which we had said was 12. Okay, so let's simplify the first one over here. We can't multiply 2 times pi if we're leaving it in terms of pi, if we're not plugging in 3.14, but we can multiply 2 times 6, which we know is 12, and then we can bring the pi back down, 12 pi. Isn't that the same thing as the 12 pi here? Yeah. So if you'll notice, I always put my constant term or my numerical term in front of pi, and then I follow that numerical term with pi. It's the same as like when we're working with variables like x or y. If I say x times 7, I don't put x7, I put 7x. Okay, so we always put our variable term at the end, and that's the same as what we're going to do with pi when we leave it as pi. Pi is always going to be at the end of our term or our expression. So they're the same, so you could use either formula, and usually if really the time that you're going to want to use this one is if you know the diameter. That way you don't have to say, well, I know the diameter is 12, but the formula is 2 pi r, so now I've got to find the radius. You don't have to do all that if you know the diameter. Okay, so let's do another example real quick of finding the circumference. Let's say this time we just know the radius. Okay, let's say that our radius is equal to 11. What's the circumference? Well, the circumference formula is 2 times pi times 11. So how would I simplify that? Yeah, 2 times 11 is, we want to go ahead and do the numerical terms. So 2 times 11 is 22, and then we can just bring the pi down on the end. Yep, 22 pi. Good job. Yeah, and if you plug in 3.14, whoops, let me let this person in. Okay, if you plug in 3.14, then you could multiply 22 times 3.14 and then get that answer too. So it depends on what the question wants you to do. And you can usually tell when we're using multiple choice quizzes and stuff in this class, if your choices are in decimal form and they don't have a pi symbol, then you want to plug in 3.14. If all of your answer choices have the pi symbol, then you don't need to plug it in. Okay, so that's kind of one way to tell, but usually the question will say leave in terms of pi if it wants you to have the pi symbol, and that's what that means. If it says estimate, then you put in 3.14. Okay, so let's move on to area now that we've done circumference. One cool thing about the area and their circumference formulas is I like to say they have the same ingredients. And what I mean by that is their circumference formula was 2 pi r. The area formula has all those same pieces. It has a 2, it has a pi, it has an r. It's just a little bit different. Yeah, I say ingredients just, I don't know why I say that. I just think it helps to kind of think about it. So the ingredients are the pieces of the formula. So it has a 2, a pi, and an r. They're just in a little bit different order. So the area formula is pi r squared. Okay, so it has a pi symbol, it has the r for the radius, but instead of being all multiplied by 2, that 2 becomes an exponent for area, for the area formula. So this time we're going to square our radius, whatever it is, and then we're going to multiply it by pi. Okay, so let's say our radius in this circle is 5. Then what would be our area? Well, we got to plug it in, right? We've got our pi symbol, we've got our radius, which now we know is 5, and we're going to square that. So what do we know about squaring a number? What does it say to do when it says 5 squared? What are we doing? Yes, that's the answer, but how do you do it? Yeah. You take the base, which is 5, the number that you're raising to the power, and you multiply it by itself that many times, whatever the exponent is. So this is saying 5 times 5, okay, which is 25. So the area here is 5 squared, which is 25, times pi. And again, since it's the pi symbol, I'm going to put it on the end of the expression there and call it 25 pi. Yeah. Okay, so 25 pi would be the answer here for the area. Hang on, I'm reading chat comments. Yes. What happens when the radius is... Oh, okay, so if we put, well, actually, I'm trying to understand the question. Do you mean instead of saying 25 pi, if we said pi 25? Is that what you're asking? Okay, I don't know if that's what the question is, but this is like what I said with like variables. We always want the pi symbol to be on the end, and we want the numerical term to come first. Oh, 25 pi is the same as 25 times pi. That's the same thing. And that's what we want it to be. Yeah. Okay, so let's do one more example of area. Let's say instead of having a radius of 5, we have a circle that has a diameter of 18. And we want to find the area. Can we find the area if we don't know the radius yet? Is there a way from this information to find the radius? Yes, there is. Okay, they didn't give us the radius, but they gave us the diameter, which we know is twice the length of the radius. So if the diameter is 18, the radius has to be half of 18, which is 9. Yeah. So the area here would be pi times the radius, which we found was 9, squared. Yeah. And then we can just simplify that again like we did the other. So 9 squared is 9 times itself, 9 times 9, which is 81, and then we'll put the pi symbol at the end. Good job. Okay, I'm really running out of time, so I got to move on to volume. And I'll just send the quizzes link out after this because I don't think we have time to play in class, but I'll send it out. Okay, for volume, we want to, so let me just explain volume real quick. Volume is how much a 3D object will hold. So how much you can fill a three-dimensional object with. And our formula is just our dimensions multiplied. But for volume, since it's three-dimensional, we have 3 dimensions. So we have length and width like we did with rectangles and two-dimensional objects, but we also have what? What else do we have in a three-dimensional object? Yeah, we have height. Okay, so that's what's different between our three-dimensional objects and our two-dimensional objects. So we've done perimeter and area of 2D objects. Now we're looking at volume of 3D. So length times width times height. So let's say we have a three-dimensional object. And I'm not very good at drawing these, but I'll try. Okay, let's say this is our object, and it has length of, it has a length of 5, it has a width of 3, and a height of 8. Okay, so we have length, width, and height here. Again, let me let this person in. Thank you. We have length of 5, width of 3, height of 8. So all we have to do is take those measurements and multiply them for volume. So it's pretty simple. We just multiply all the numbers together that we have. 5 times 3 times 8. So we would multiply those. Yeah. And that would be our volume. So this would be 120. And I like how some of y'all in your answers gave me cubic units. That's awesome. So since I didn't give you the units, then you don't know if it's inches or centimeters. So you would just say units, but they are cubed because it was 3 units multiplied. So 5 units times 3 units times 8 units, 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 units. So it's cubic units. Good job. Okay, so that is the volume formula. Now the other thing that you're going to be doing with volume is finding a missing measurement. So let's say you know the volume of an object, I'm not going to draw it this time, is equal to, let's see, I did one example somewhere. I'm just going to make it up. Let's say we know the volume is equal to 60 cubic inches. Okay, and we know that, let's see, I got to make this up, hang on. Okay, let's say we know the height is 10 and we know the length is 3, but we want to know what the width is. Can we find one of the missing measurements if we know the volume and 2 of the other measurements? Yes, we can. Yes, you're right. Okay, some of y'all have already gotten the answer. How'd you get the answer if you already got it? Or if you haven't gotten it, how do you think you're going to get it? Yeah, okay, so we know the volume has to be length times width times height. So we know the length is 3. We don't know the width, so I'm going to put W, but we do know the height is 10. So we know we had to multiply all these to get 60. Well, we can go ahead and multiply the ones we do know. 3 times 10, which is 30. And now we just need to know what times 30 equals 60. Well, we know we can either just say, well, we know 30 times 2 equals 60, or if we don't know it, we can divide 60 by 30 because we're solving for W, and we need to do the opposite of multiply by 30. So either way, you would get width is equal to 2. So that's another example of problems that you're going to see in the volume lesson, where you're solving for one of the measurements. So that's the volume. Okay, and I'm pretty much out of time, so I'm going to go ahead and stop here for today. But I will send out that quizzes practice link since I know we're not going to have time to do it all in 4 minutes. But I will send that out, and you can use it to practice just for yourself.